Hello everyone. In this video, I'd like to go over a couple of examples to illustrate how you can go about finding limits analytically. So here we have to find the limit of this rational function. If I attempt to plug in, it's a closed form function, meaning I can plug in for the value I'm looking for the limit within that neighborhood of that value, the value 2. But if I plug it in right away, I end up with a fraction with 2 on the bottom. 2 minus 2 is 0. So I can't afford to plug in 2 for x at this point. But what I can do is transform my fraction into an equivalent fraction, and for which I'll be able to plug in a fraction that's actually defined at x equals 2. So upon factoring my numerator into x minus 1 times x minus 2, my fraction then turns into this equivalent fraction. And at this point, the common factors x minus 2 can cancel each other out. And therefore, my fraction turns into an equivalent function that's a linear function for which I can plug in 2 for x because it's defined at x equals 2. So the way this works is I turn my limit as x approaches 2 of f of x into the limit of a factor. First, of course, I show my work, I factor out, I show how my common factors canceled out, so that the limit of f of x turns out to be the limit of x minus 1 as x approaches 2. And because it's a closed form function, I can turn x into 2, i.e. plug in 2 for x to get my limit. So my limit is 1. Some of you may wonder what happens if it's a piecewise function. Well, the exact same thing happens, but it's slightly different this time. Because it's a piecewise function, I need to rely on the definition of the limit, the existence of a limit. So here I have two pieces, depending on whether x is less than 2 or 2 or both. So what I do, this is, by the way, this is my f of x function. It's a piecewise function. So let me find the left limit. So the limit as x approaches 2 from the left of that function f of x. Because I'm approaching 2 from the left, I'm going to rely on this part of my function, this piece, the piece that only leaves for x's less than 2. So the f of x at that point is a closed form function, which is x squared minus 1. And therefore, I can plug in 2 for x and get my limit of 3. So that's the left limit. To get the right limit, I proceed a similar way, which is I use the fact that my function is piecewise, and because I'm approaching from above 2, f of x takes on the value x minus 1. Which is a closed form function, and therefore I can plug in 2 for x to get my limit of 1. And in this instance, the left and right limits happen to be different from each other, which means my limit does not exist. So I can conclude that the limit of f of x as x approaches 2 does not exist. If the two limits had been equal to each other, so if the two limits did exist and were equal to each other, then my limit would have existed and would have been equal to that common limit. See you on the next video.